Hey guys, one more video here on a very short one with more applications and normal distributions. The same stuff we did class today or yesterday, depending on when you're watching this. And I just want to make sure we got it down really good. So just one quick example, question at the end. So here we go. The question says, earthquakes based on data set 16 in Appendix B, which we don't really need to look at, assume that the Richter scale magnitudes of earthquakes are normally distributed with a mean of 1.184 and a standard deviation of 0.587. Part A, earthquakes with magnitudes less than 2,000 are considered micro earthquakes that are not even felt. What percentage of earthquakes fall in this category? Well, to make it on a standard normal curve, I went ahead, first of all, found the z-score. That's what you're looking at right here. Found a z-score of 1.39. Drew my picture, which is going to be very important today. And simply because it said less than, I shaded it to the left, which is exactly what I can use my technology to find. And so when I found the 1.39 z-score and less than that, I found it was 0.9177. And it did ask me what percentage, so I moved a decimal over a couple of spots and got 91.77%. No big deal there. Part B says earthquakes above 4.0, the keyword being above, will cause items to shake. What percentage of earthquakes fall in this category? So that's going backwards. That's asking me, instead of asking me for the z-score or the percent, well, it's asking me the same thing. What percentage cause it to fall in that category? Easy for me to say. I'm stumbling all over the place. So I found a z-score again. This time I found a z-score was 4.8, and that is a very high z-score. I mean, extremely high. Even my picture here doesn't really do it justice. It should be even further along than that. That's more than 4 standard deviations away from the mean. There's hardly any area over there. And that's what I found out. When I looked it up, or punched it in my calculator, I got 0.0001, and it asked me for percentages again, so I said, okay, it's 0.01%. It shows you how little tiny space it actually is over there. And then part C, the last thing. Find the 95th percentile. Will all earthquakes above the 95th percentile cause indoor atoms to shake? So let me move this stuff up right here a little bit and blow this up down here. Whoa, there it is. Drew the picture, first of all. 95th percentile is 0.95 in the yellow shaded region. At least I tried to shade it yellow. And then 0.05 up here. That's the area. So I found the z-score for, 95% of the area. And it was the inverse z-score right there. And I got the z-score of 1.645. But it's not asking me for the z-score. It's asking me what x is there. I need the x value. Now I'm going to basically find what the x was to provide the z-score. So we did this formula yesterday. If you're looking for the x, you do the z-score times the standard deviation plus the mu, and I got 2.15. Well, because 2.15 is not quite 4, not even close to 4 really, as far as the earthquakes go, that means at the 95th percentile, not all the earthquakes will cause things to shake. That's all that means. So just a quick review, making sure you still had it. Watch for the question here in a second on the end. Answer it, get it correct, and I'll see you tomorrow. Bye.